Hello, and today we'll talk about hydrocarbons. What are hydrocarbons? Hydrocarbons are compounds that contain only carbon and hydrogen. Hydrocarbons are the simplest type of carbon-based compounds. Nonetheless, they can vary greatly in size. Smallest hydrocarbon just has one or two carbon atoms, but larger hydrocarbon may have hundreds. Size of hydrocarbon molecule influences their properties. For example, it influences their boiling and melting point. The result, some hydrocarbons are gas at room temperature, while others are liquid or solid. Hydrocarbons are generally nonpolar and do not dissolve in water. In fact, they tend to repel water. That's why they are used in floor wax and similar products. Hydrocarbons can be classified to basic classes. Class are saturated hydrocarbon and unsaturated hydrocarbon. The classification is based on the number of bonds between the carbon atoms. Saturated hydrocarbon contain only a single bond between carbon atoms. They are the simplest hydrocarbon. They are called saturated because each carbon atom is bonded to as many hydrogen atoms as possible. In other words, the hydrogen atoms are saturated with hydrogen. See an example of a saturated hydrocarbon. Each carbon atom is bonded to 3 hydrogen atoms. This compound, which is named acene. Saturated hydrocarbons are given general name of alkanes. The name of specific alkanes was ending in A and E. First part of the name indicated how many carbon atoms in each molecule. The alkane has the smallest alkane is missing. It has just 1 carbon atom. Next largest is acene, 2 carbon atoms. Boiling and melting point of alkaline determined mainly by the number of carbon atoms they have. Alkaline has more carbon atoms, generally have higher boiling and melting points. This table shows only alkalines with relatively few carbon atoms. Some alkalines have many more carbon atoms. Property might larger alkalines have. For example, do you think that any of them might be solids? Shape of alkalines. Structural formulas are often used to represent hydrocarbon compounds because the molecule can have different shapes, structures. Hydrocarbon may form straight chains, or branch chains, or rings. In straight chain molecules, all the carbon atoms line up in a row like cards of the train. They form what is called the backbone of the molecule. In branch the chain molecule, this one of the carbon atom branch off to the side from the backbone. In single molecule, the chain of carbon atom is joined at the two ends to form a ring, isomers. Even compounds with the same number of carbon and hydrogen atoms can have different shapes. The compounds are called isomers. Look at the structural formula of butane, and its isomer isobutane. Both molecules have 4 carbon atoms and 10 hydrogen atoms, but the atoms are arranged differently. Butane is a straight chain molecule. As butane is branched, you can see 3-dimensional model of these 2 isomers at the URL below. You can rotate the molecule model to get a better idea of their shapes. Isomers usually have somewhat different properties. For example, straight chain molecule generally have higher boiling points and melting points. Their branch chain isomers, the boiling and melting points of isobutane are -12 Celsius and minus 160 Celsius, representatively. Cycloalkanes, ring-shaped alkanes called cycloalkanes. They usually contain just 5 or 6 carbon atoms because larger rings are not very stable. However, a ring can join together to create a larger molecule consisting of 2 or more rings. Compared with straight, branched chain alkanes, alkanes have higher boiling and melting points. Unsaturated hydrocarbons. Unsaturated hydrocarbons contain at least one double or triple bond between carbon atom. As a result, carbon atoms are unable to bond with as many hydrogen atoms as they would if they were joined only by single bonds. This makes them saturated with hydrogen. Unsaturated hydrocarbon classified on the basis of their bond as alkynes or aromatic hydrocarbons. Alkynes, unsaturated hydrocarbon that contain at least one double bond called alkynes. The name of a specific alkene was ending in ene was a prefix indicating the number of hydrogen atoms. Alkaline that has two carbon atoms is named as syn. Syn is produced by most fruits and vegetables. Its speeds of ripening and also rotting. We can see the effect of syn on bananas, like alkalines. Alkaline can have different shapes. They can form straight chains, branch chains, or rings. Alkaline can also form isomers, or compounds with the same atom but different shapes. Generally, the physical property of alkalines. Similarly to these alkalines, smaller alkalines, such as syn, have relatively high boiling and melting points. They are gases at room temperature. Larger alkalines have lower boiling melting points. They are liquid or actually solid at room temperature. Unsaturated hydrocarbon that contain at least one triple bond called alkylines. The name of special alkenes always ending Y and E, the prefix for the number of carbon atoms. Smallest alkaline called ethylene, which has just two carbon atoms. Ethylene is also acetylene. This burned in acetylene torches. The acetylene produces so much heat, it burns that it can melt metal. Breaking all this bond between carbon atoms releases a lot of energy. These two bunches of bananas were stored in different ways. The banana on the right was stored in the open air. The banana on the left are stored in a special bag that absorbs syn. They release the banana in the bag have not yet turned brown because they were not exposed to syn. Alkali may form straight or branch chains. They rarely occur as cyclones. In fact, alkalines all shapes are relatively rare, and the least in nature. Aromatic hydrocarbon. Unsaturated cyclonic hydrocarbon are called aromatic hydrocarbon. That's because they have a strong aroma or scent. Their molecules consist of 6 carbon atoms in a ring shape, connected by alternating single and double bonds. Aromatic hydrocarbon may have single ring, multiple rings joined together by bonds between their carbon atoms. Benzene is the smallest aromatic hydrocarbon. It has just one ring. Benzene has many uses. For example, it is used in air fresheners and mothballs because of its strong scent. Uses and source of hydrocarbon. It's hard to discover overstate of the importance of hydrocarbon to modern life. Hydrocarbon have even been called the driving force of Western civilization. Most important use as the fuels: gasoline, natural gas, fuel oil, diesel fuel, jet fuel, coal, kerosene, and propane. Just some of the hydrocarbon compounds that are burned for fuel. Hydrocarbons are also used to manufacture many products, including plastic and synthetic fibers such as polyester. Main source of hydrocarbon is fossil fuels: coal, petroleum, natural gas. fossil fuel from over 100 million years when dead organisms are covered with sediment and put under great pressure. Giant ferns in ancient swamp turned into coal deposits. Dead organisms in ancient sea gradually form a deposit of petroleum, natural gas, summary, hydrocarbon compounds that contain only carbon and hydrogen. They are the simplest of carbon-based compounds. Saturated hydrocarbons contain only single bond between carbon atoms. They are also called alkanes. They may form straight chain, branch chain, or sampling molecule compounds with the same number of atoms but different shapes are called isomers. Saturated hydrocarbon contain this one or double saturated hydrocarbon contain at least one double or triple bond between carbon atoms. Hydrocarbon with double bonds are called alkanes. With triple bond are called alkanes. Aromatic hydrocarbon consists of 6 carbon atoms in a ring shape connected by alternating single and double bonds. Hydrocarbons are extremely important to modern life. The most important use is as fuels. Hydrocarbons are also used to manufacture many products, including plastics. Main source of hydrocarbons is fossil fuel. Thank you very much.